So listen, I have discovered an awesome proof about prime numbers. It says that there are infinitely great amount of prime numbers. Basically, no matter what number you take, if it's p of 1, p of 2, p of 3, p of n, that p is prime or p of plus 1 is even. But if you divide p plus 1, which is an even number plus 1, divide it by a prime number, it comes out to be prime, which creates another new prime number in the p series. So it doesn't create a p of 1 or p of 2 or p of n, whatever you say. It's up to you. See you judging me. It makes a new p series, and so you have a lot of p's, an infinitely large amount of p's. So therefore, there's an infinite amount of p's.
Alright, Euclid, I can do you one better. I've been looking into Fermat numbers, okay? So these are positive integers that are of the form fn equals 2 to the 2 to the n plus 1. Okay, where n is going to be a non-negative integer. So, for example, you've got 3, you've got 5, you've got 17, you've got 257. So all of these Fermat numbers, they're pairwise relatively prime. And all that means is that any pair of items on this list, the greatest common divisor is going to be 1. The set of all Fermat numbers is therefore pairwise relatively prime. So what that's saying is that if you choose a prime divisor, Pn, for each Fermat number, Fn, by this premise, we know that all of these primes are distinct, showing that there are infinitely many primes.
Listen to me, you Zeitgeist. Unser Wusste war Funderbug, and if we define a topology on the set of integers by using the arithmetic progressions from negative infinity to positive infinity as a basis, this yields a topological space, which is a set of points that satisfies these conditions. First, the empty set, and both in the variables or any collection of open sets is an open set. Then, the intersection of any collection of open sets is an open set. God. Now for each prime, let's say P, let A sub P consist of all multipliers F sub A, P. Then, A sub P would have to be closed since its complement is to the union of all the other arithmetic progressions with difference of P. Let A be the whole union of the progressions A sub P. If the hashtag of prime is finite, A is finite of closed sets. Therefore closed. But all integers except negative 1 and 1 are multipliers of some prime. So the complement of A is squiggly line negative 1, comma 1 squiggly line, which is obviously not open. This shows A is not a finite union, and there are infinity many possibilities in primes, you fools.
It's a number greater than 1. Divisors, it's got none. The only number that goes into it is 1. If I think hard, I think I could name some. I will try until I got it. These numbers are prime and not composite. A lot of people might not know, but I think I'll give it a go. This is my prime song. I sing it all the time song. Gotta give it a try song. So many numbers, one than another. I sing my prime song, and I don't really care if nobody else will hear, 'cause I've still got a lot of prime numbers here.